JUnit is a habit, not an afterthought. Appendix F. JUnit Essential Helper Classes. JUnit Essential Helper Classes. There are 4 essential helper classes in JUnit, most usable for writing extensions and custom test engines. They are Annotation Support, Class Support, Reflection Support, and Modifier Support. Let us take a look first at the Annotation Support class. This class provides static utility methods that operate on annotated elements. That is, on packages, annotations, classes, interfaces, constructors, methods, and fields. These include methods to check whether an element is annotated or meta-annotated with a particular annotation, to search for specific annotations, and to find annotated methods and fields in a class or interface. Some of these methods search on implemented interfaces and within class hierarchies to find annotations. Let us take a look at the JUnit's Annotated Support API. You can get the PDF for this appendix from the course's website in order to access the above URL. So we will now switch to the online API in order to review it further. Alright, and we see here Annotation Support JUnit 5.6.2, and that is what we will be renewing today. So Annotation Support provides static utility methods for common tasks regarding annotations. For example, checking if a class, method, or field is annotated with a particular annotation, finding annotations on a given class, method, or field, finding fields or method annotated with a particular annotation, etc. So test engine and extension authors are encouraged to use these supported methods in order to align with the behavior of the JUnit platform. Now let's look at the classes, at the methods that this class presents to us. So public static boolean is annotated, determines if an annotation of annotation type is either present or meta present on a supplied optional element. So the full signature is public static boolean is annotated, optional type of anything extends annotated element, class of anything extends annotation type. So what I'm going to do for the future methods, I'm not going to give the complete signature. What I'm going to do, I'm just going to give the name of the class. Alright. Next method is Annotated, which is an overload of this method. And this method determines if an annotation of annotation type is either present or meta present on the supplied element. So it doesn't have an optional here, it just has the annotated element class instance. Right, find annotation. You can use this method to find the first annotation of annotation type that is either present or meta present on the supplied optional element. And you are very welcome to review the full signature. It's just if I spell out the full signature, you're likely to get confused because there is just a lot of generics. Alright, next is an overloaded method called find annotation, and what it does is finds the first annotation of annotation type that is either directly present, meta present, or indirectly present on the supplied element. So if the element is a class and the annotation is neither directly present nor meta present on the class, this method will additionally search on interfaces implemented by the class before finding an annotation that is indirectly present on the class. Next method is find repeatable annotations. So it finds all repeatable annotations of the supplied annotation type that are either present, indirectly present, or meta present on the supplied optional element. Alright, next is find repeatable annotations and overload, and it finds all repeatable annotations again of the supplied annotation type that are either present, directly present, or meta present in the supplied annotated element. So this method extends the functionality of annotated element get annotations by type class with additional support for meta annotation. And you're welcome to freeze the course and to read this. If the Javadoc is lengthy, I'm going to read just the first couple of lines, and you're welcome to freeze the progression of the course in order to read whatever follows. Next method is find public annotated fields, and it finds all public fields of the supplied class or interface that are declared to be of the specified field type and are annotated or meta-annotated with the specified annotation type. Alright, so console to the Javadoc for class.get fields for details on inheritance and ordering. Next method is called find annotated fields, and it finds all fields of the supplied class or interface that are annotated or meta-annotated with the specified annotation type using top-down search semantics within the tab hierarchy. Fields declared in the same class or interface will be ordered using an algorithm that is deterministic but intentionally non-obvious, like many things that JUnit orders are deterministic but intentionally non-obvious. And the results will not contain fields that are hidden or synthetic. Alright, find annotated fields overload is the next method, and it does exactly the same thing as the previous one, so I'm not going to, but it has a slightly different signature obviously, so I'm not going to repeat it. Find annotated field values is the next method, and it finds the values of all non-static fields of the supplied instance. An instance of an object is supplied that are annotated or meta-annotated with a specified annotation type using top-down search semantics within the type hierarchy. Values from fields declared in the same class or interface will be ordered using an algorithm that is, well, you guessed it, deterministic but intentionally non-obvious. That was probably the best approach to use, and JUnit designers and developers used it to great advantage. So the results will not contain values from fields that are hidden or synthetic, just like several methods here before. An overload find annotated field values. So it also does exactly the same thing as this previous method, except it has a slightly different signature. It takes a class object instead of an object instance. Alright, find annotated field values as second overload, and it does exactly the same thing as the previous two. So let's go to the next one. A third overload, find annotated field values, does exactly the same thing. So I'm gonna skip it. And last but not least is the find annotated methods method. It finds all methods of the supplied class or interface that are annotated or meta-annotated with a specified annotation type. So that is basically the review for annotation support. Let us go back to the actual appendix, and let us go to the next slide. Next is the class support helper class. Class support provides static utility methods for working with classes, that is, instances of java.lang.class. Let us now switch to the online API for class support. This API is available through this link, to which we are going to switch right after this slide. JUnit's class support API. And of course, you are able to control click on it from the PDF file that represents this appendix on the course's website. Let us switch to the class support Javadoc. And so again, we see that class support provides static utility methods for common tasks regarding classes. For example, generating a comma-separated list of fully qualified class names for a set of supplied classes. And again, test engine and extension authors are encouraged to use these supported methods in order to align with the behavior of the JUnit platform. In other words, don't reinvent the wheel. Alright, let's take a look at the two methods within this class. Null saves to string generates a comma-separated list of fully qualified class names for the supplied classes. And its overload, null save to string, does exactly the same thing. It generates a comma-separated list of mapped values for the supplied classes, except the values are generated by the supplied mapper. That is class column get name. I hate this two columns, but class column get simple name, etc. Unless a class reference is null, in which case it will be mapped to null. So it basically uses method references to get names of the classes. Alright, let us go back to the appendix and let us go back to the next slide. Next is the reflection support helper class. Reflection support provides static utility methods that augment the standard JDK reflection and class loading mechanisms. These include methods to scan the class path in search of classes matching specified predicates, to load and create new instances of a class, and to find and invoke methods. Some of these methods traverse class hierarchies to locate matching methods. In order to review the Reflection Support API in more detail, we are going to switch to the following link: JUnit's Reflection Support API. And again, you can get to this link by taking a look at the respective PDF representing the PDF for this appendix. And it is found on the courses website. Please follow me in order to explore this helper class in more detail. And let's switch now to the Javadoc for reflection support. So what does it say? Reflection support provides static utility methods for common reflection tasks. For example, scanning for classes in the class path or module path, loading classes, finding methods, invoking methods, etc. Test engine and extension authors are encouraged to use the supported methods in order to align with the behavior of the JUnit platform. And let's take a look at the methods provided by this class. Alright, load class. Well, it's deprecated. Please use try to load class instead. So this method loads a class by its primitive name or fully qualified name using the default class loader. Class names for arrays may be specified using either the JVM's internal string representation, that is square brackets opening, I for double array of integers, int array, or square brackets opening L java.lang.string for Java dot and comma, or whatever it's called in English, for java.lang.string array, etc. Semicolon it's called. Pardon me, all day today I'm swimming in Russian. Or source code syntax, that is int array, java.lang.string array, etc. Alright, next method is try to load class. Try to load a class by its primitive name or fully qualified name using the default class loader. Class names for arrays may be specified using either the JVM's internal string representation, blah blah blah, or source code syntax, blah blah blah. It's exactly the same as here, and I literally almost broke my tongue speaking it, so please read it, because I'm not going to repeat it. Alright, next one is find all classes in class path root. This method finds all classes in the supplied class path root that match the specified class filter and class name filter predicates. The class path scanning algorithm searches recursively in subpackages beginning with the roots of the class path. Next is find all classes in package. And this method finds all classes in the supplied base package name that match the specified class filter and class name filter predicates. The class path scanning algorithm searches recursively in subpackages beginning within the supplied base package. Now, the next one is find all classes in module. Finds all classes in the supplied module name that match the specified class filter and class name filter predicates. The module path scanning algorithm searches recursively in all packages contained in the module. Alright, next method is new instance. It produces a new instance of a object, of a certain class. So it creates a new instance of the specified class by invoking the constructor whose argument list matches the types of the supplied arguments. The constructor will be made accessible if necessary, and any checked exceptions will be masked as an unchecked exception. Alright, invoke method is the name method, is the next method. Invokes the supplied method, making it accessible if necessary, that is key, and masking any checked exception as an unchecked exception. Find fields is the next method. It finds all fields of the supplied class or interface that match the specified predicate. Fields declared in the same class or interface will be ordered using an algorithm that is deterministic but intentionally non-obvious, and the results will not contain fields that are hidden or synthetic. Next method is try to read field value. Tries to read the value of a potentially inaccessible field. So if an exception occurs while reading the field, a failed try is returned that contains the corresponding exception. A try is a kind of an optional augmented with the ability to tell you what exception occurred that caused an object not to be returned, but instead an exception to be thrown. It contains the exception as well. Find method. It finds the first method of the supplied class or interface that meets the specified criteria, beginning with the specified class or interface and traversing up the type hierarchy until such a method is found or the type hierarchy is exhausted. And the algorithm does not search for methods in object, so it skips the top of the hierarchy. The next one is an overloaded find method, and it finds the first method of the supplied class on interface that meets the specified criteria, beginning with the specified class or interface and traversing up the type hierarchy until such a method is found or the type hierarchy is exhausted. So it does exactly the same thing but has slightly different signature. The algorithm does not search for methods in objects, so it stops at the top of the hierarchy. The next one is find methods. And basically it finds all methods of the supplied class or interface that match the specified predicate. The results will not contain instance methods that are overridden or static methods that are hidden. That is very important. So it will not contain instance methods that are overridden or static methods that are hidden. Alright, so if you are looking for methods annotated with a certain annotation type, consider using annotation support that find annotated methods, class, hierarchy, traversal mode. So last but not least, class within the reflection support is the find nested classes method. It finds all nested classes within the supplied class or inherited by the supplied class that conform to the supplied predicate. This method does not search for nested classes recursively, so keep that in mind. And as of JUnit Platform 1.6, this method detects cycles in inner class hierarchies, from the supplied class up to the outmost enclosing class, and throws a JUnit exception if such a cycle is detected. Cycles within inner class hierarchies below the supplied class are not detected by this method. Alright, so let us switch back to the appendix and let us go to the next slide. Last but not least is the modifier support helper class. This helper class provides static utility methods for working with member and class modifiers. For example, in order to determine if a member is declared as public, private, abstract, static, etc. We can review this helper class in more detail online at the following link, JUnit's Modifier Support API, that you can get from the commensurate PDF on the course's website. Please follow me to explore this last helper class. Alright, modifier support provides static utility methods for working with class and member modifiers. For example, to determine if a class or member is declared as public, private, abstract, static, etc. Test engine and extension authors are encouraged to use these supported methods in order to align with the behavior of the JUnit platform. Let us review the methods of this modifier support class. The first such method is public, and it determines if the supplied class is public. The second method is overloaded is public, and it determines if the supplied member is public. Next is private, and it determines if the supplied class is private. Next is the overload is private, and it determines if the supplied member is private. Next is not private, and it determines if the supplied class is not private. In other words, this method will return true for classes declared as public, protected, or packaged private, and false for classes declared as private. Right, overloaded is not private, determines if the supplied member is not private. In other words, this method will return true for members declared as public, protected, or packaged private, or default visibility, and false for members declared as private. Next is abstract, determines if the supplied class is abstract. Next, an overload of is abstract, determines if the supplied member is abstract. Next is static, determines if the supplied class is static. Next is static, determines if the supplied member is static. Next is not static, determines if the supplied class is not static. Next is an overload is not static, determines if the supplied member is not static. Next is final, determines if the supplied class is final. Next is not final, determines if the supplied class is not final. Next is an overload of is final, determines if the supplied member is final. And next is an overload of is not final, determines if the supplied member is not final. Now let us switch back to the appendix and let us go to the next slide. So to rehash, in this appendix we reviewed the following helper classes which make working with custom extensions and with custom test engines far easier than if their functionality had to be written from scratch. Annotation support, class support, reflection support, and modifier support. You will find that you will use these helper classes when writing non-trivial custom extensions and non-trivial test engines. Please take the time to learn these helper classes in depth. In the last appendix, we will take a look at some Mockito methods. Mockito is a mocking and stubbing framework that works nicely with JUnit, and everybody, whenever you have a JUnit course, asks for some Mockito coverage. Now remember, we will provide some basic Mockito coverage on the next appendix, but we are working on GRG-003, JUnit, and Mockito as a habit, not an afterthought course that will have expert level in-depth treatment of JUnit and Mockito together. And as always, keep your motivation high.